Stage is yours.
Thanks a lot. So welcome. I'm a little bit overwhelmed, to be honest. But to get the room a little bit more free, I will first set a little bit of expectations. Then you have time to flee for other talks or something like that. Because what I'm not going to do today is talking about what resilient software design is or how to implement that in detail. So if you're, it's more about the lessons learned or what I learned, what is going wrong usually on your way doing that. And most of the time, these things are not exactly like understanding how to implement a circuit breaker or something like how to use a back pressure or something like that. Very different things that are usually getting in your way. It's not only related to resilient software design, or some of the topics are not and some are. So that's what I'm going to talk about. So, and the second challenge is this will be usually that is a 1 hour talk, and we've got about 45 minutes, so be prepared for a little bit of a fire hose. I try to make that as convenient as possible still. But before we really start up, who does not know what resilient software design is at all? Okay, a few hands. So, resilient software design in 1 minute. In 1 minute. So basically every system we face these days is distributed, either communicating in a distributed environment or distributed in itself, like microservice architecture or something like that. And in a distributed environment, we will see something about that on the slides later on, you can no longer rely on the infrastructure fixing every type of potential technical error that you might face. It will hit you on the application level, and you have to build measures against these technical failures that will hit you, basically, in order to deliver a highly reliable or highly available application, even though it runs in a distributed environment. So that's basically what resilient software design is about in 30 minutes or seconds or something like that. So on the end, this is a huge topic, so talking about that, I will give a workshop about that tomorrow, and it will still just reveal as much as that, even though we are using a whole day for that, and so lots of stuff. But as I said, the real problem usually isn't understanding that stuff. You're really great in that. I know that. You're really good in that, reading that, picking up those ideas, what the patterns are, how to implement those patterns and all that stuff. The problems are somewhere else. Before we dive into that, just, again, not a minute, 30 seconds. My name is Uwe Friedrichsen. I work for a company you probably never heard of because it's located in Germany. And so no words about those. And probably the most interesting thing on that slide is the SlideShare account where you can download the slides. And so if you want to if you think it was useful and you want to have a look at that afterwards. But that should be sufficient about me at the moment. And let's dive in. So for the motivation, I said, assume you want to do resilient software design. You heard something about that, you read about something about that. Maybe you attend the workshop tomorrow, whatever you're doing, and you say, yeah, that's cool. I think we need to do that in our company. You say, but it's an obvious thing, so everybody needs to understand that, and it should be easy, like being on a vacation on the beach with a cool drink in your hand, slight breeze, something like that. It will be straightforward. I mean, it's so obvious. We need that. We have to do that. And then suddenly it feels a little bit more like that. Say, whoa, what's going on there? Or you feel like you're standing in the middle of a thunderstorm and say, why? Why doesn't it work? Why don't the people pick it up? Where's all this resistance coming from? What's going wrong here? And yeah, so what the heck went wrong? It was heck in there. Yeah. And at least from my experiences in the last 5, 6, 7 years. So I'm working with distributed systems for more than 20 years now, but especially in cloud microservices, architecture and landscapes and so on for the last 6 or 7 years or something like that, seeing a lot of customers, seeing a lot of projects, picking those ideas up. I figured out there are some challenges around which you need to take care of. These are not all the challenges I have, but I collected 7 of them. So the 7 most popular pitfalls I've seen. And to give it a more dramatic twist, I call those quests. I mean, it's a cooler word, isn't it? Like, pitfall sounds so negative. Quest sounds cool. So yeah, it's a quest. Let's go for it. So, quest number 1. The business case. Now you would say, boah, no, not a business case. Go away with that. That's what other people are doing. We're developers, so we are not talking about business case. That's boring stuff. What the heck do you want from me? The problem is that your ideas, as brilliant as they might be killed off before you have even started, if you're not at least able to talk a tiny bit about that with the people who decide about it. So, for instance, if you go to your manager and say, manager, we need to pick up resilient software design, then quite often you get a question like, okay, how much money are you going to make with that? You say, yeah, no, I don't know. Are we doing any money? I don't think so. And okay, get away. Or if you go to your project manager or product owner or something like that, we have to pick up resilient software design. Are we going to get any faster by doing that? So delivering earlier, so, and you say, no, I don't think so. Okay, dismissed again. And actually also indirectly asking for, are we going to make money? What's the business case of that? And it's not because they're just stupid like hell or something like that. Okay, there are persons who are, or at least feel like that. But it's not the point. The point is that they have to make commercial decisions, and we have to help them to make the right decisions. So, and the problem with resilient software design is, it's not about making money, it's about not losing money. So the business case is inverted business case, basically. What do I mean with that? The point is, if you don't do it, so you have to compare doing it and not doing it, you will have reduced system availability due to the non-determinism of distributed systems. So you're not prepared for dealing with the problems that will distributed systems give you. This results in the fact that your users cannot do what they want to do. And this has 2 effects, basically. The one is, you get less transactions per period. You lose money. So usually you build your systems for making directly or indirectly some kind of revenue, improving your business. And if your users can't use the system, either your internal or your external users, then you're losing the opportunities. You lose money by not being resilient. And the other one is, users really get annoyed over time if that happens over and over again. So they will walk away to your competitor whose systems run reliably. And so it's called churn rate in marketing terms. And so it's delayed revenue cost. And these are the 2 things that give you the budget for doing resilient software design. By the way, it gives you budget, but it also limits your budget. You have to talk about that, you have to negotiate that. It's great if you have some numbers, some monitoring around, so about system outages, how much money you've lost. Usually you don't have that. But if you have it, use it. If you don't have it, just negotiate with your peer, okay, how much money does that usually cost if my system is down for an hour per month or something like that? And usually these are huge numbers. That's quite a big budget that you have to invest. Okay, so much for business cases. As I told you, yeah, it's boring stuff. On the other hand, if you call yourself a software architect, you most definitely have to be able to talk about that, not only picking up frameworks. That's part of a software architect's work. So, and if you don't want to do that, never become a software architect. Also a word of advice. But even if you call yourself a senior developer, you also should be able to talk a little bit about that to make sure that the right decisions are made. It's not about, let's put it the other way around. It's about helping your other stakeholders making the best decisions possible, giving them your knowledge and helping them to make the right decisions. And business case is a little bit about that. But let's move on to the next one. I mean, that was an esoteric one, so let's go more for a technical one. Distributed systems themselves. So I talked a little bit about this, or I mentioned the non-determinism of distributed systems, and people usually tend to say, yeah, and they don't get at all what that really means. So I think about 1 or 2% of the developers and architects and however they're called in their roles, or IT folks I've seen in IT really understood the implication of distributed systems. So Werner Vogels is one of them who really understands that, CTO of Amazon. And that's what he says about distributed systems, basically. And he really knows that. And it's not because people are dumb, it's because I think mostly the way we were trained and so learning how to do IT stuff and the way our brain works. And just to make you, give you a little bit idea. So on the left side, what we learned in IT education, on the right side, what we actually need. What we learned is something like, if this, then that. So deterministic behavior, basically. Reasoning about deterministic behavior, so breaking down our problems into chunks and making all these loops and so on, or doing it the functional way, blah, 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 and so on. So a complicated system design. By the way, this is how our brain works. It works great this way. We are good in doing that. And it's a good idea to do that if you reason about solving a problem inside one process, inside a process boundary. On the other hand, if you go into the distributed world, you will face something like, if X, then maybe Y. And this maybe actually changes everything, because it's no longer deterministic. So across process thinking is non-deterministic behavior. And this non-determinism, this might happen or not, or partially, or later, or in a different order, and all these things are really, really hard to reason about. And I've rarely seen people who are really able to do that. I wouldn't say that I do that perfectly either. At least I accept the fact that this stuff is non-deterministic, which is a good starting point, actually. And again, our brains are really poor at that, and our whole IT education usually just goes on the left side. So whatever we learn, we always pretend we are in a inside a process. And even our industry, what are they giving us for handling these kind of systems? They're going this way, basically. So they are saying, yeah, like we've seen with DCE, with Corber, with the .NET distributed objects, or with the Java EE, EJBs, and all this other stuff which we've seen with, in the SOAP community. So here's an interface which looks like it would be a local communication, and we're hiding the whole complexity for you, which doesn't work, actually. I mean, if you go distributed, you have types of failures which you will never see inside a system, like, okay, the other system is crashing, which is the easiest one, or it partially answers, or it doesn't answer, so it goes brittle, or timing, the arch enemy in distributed system. Timing failures, latency will bring you down, bring down your whole system landscape faster than you can grab a coffee. And you're completely surprised by that. Response failure, giving the wrong answers, but fortunately in time. And by the Byzantine failures, like running amok or something like that. All that stuff is going to happen to you. And while this looks quite okay and say, yeah, it's okay, it has a lot of effects. There are a lot of papers out there. The oldest one up in the left corner from 1978. So almost 40 years, so next year it's 40 years old, which already describe, hey, a lot of things which you think are for granted when you are going to design a system are not. They're really hard, like getting consensus under certain conditions. So time and ordering on all that stuff here. Byzantine failures and blah, 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 or everything around. So consistency, all these things. So to wrap that up, basically, is if you talk about distributed systems, and be aware of that, you're always talking about distributed systems these days. Even your simple intranet application usually consists of a web server, an application server, and a database. 3 parts, remotely communicating. So, and your whole system landscape is distributed usually. So even in a conservative company, you're usually talking to 10 or 20 or 50 other systems online. And if you're going microservices and so on, and you're also internally doing that. So you're running in a distributed world these days. Mobile IoT, not even mentioned right here. And distributed systems really introduce non-determinism regarding execution completeness. Will it ever complete, or will you get a distorted, partial answer? Will you get it in the right order? So happens before, a really big problem. So did A happen before B? Can you really decide which is easy inside a process and which is a real huge issue across systems boundary, process boundaries on communication timing, latency? So takeaway, if you talk a reason about distributed systems, is you will be affected by these things on the application level. I mean, in the earlier years, what you did for high availability is buying a highly available server or something like that, or setting up a cluster or something. All these things, solving it on an infrastructure level, because you didn't have the remote communication. So it was just your one process running on one machine. And this is the easy thing to handle. Distributed world is different. So it will hit you in the application level. Infrastructure won't save your ass. And so at least have a plan how to detect that and handle it if it's going to hit you, the application. Okay. Enough words. It's a really tough one. So again, as I said, I see most people struggling with that. That's really hard to accept because our brains are just trying to prevent accepting that. And, oh no, that's too hard. Let's reason about something. So related to that, but a little bit easier, is the 100% available trap, which is a little bit easier solved. There are several versions around for the 100% available trap. The first one is you go to your product manager, your product owner, however it's called, and you say, how should the application respond if this kind of technical errors is going to happen? And your business owner is going to reply, this must not happen. It's your job to make sure that it does not happen. And you say, well, I mean, probability that this is going to happen is higher than 0%, so it's not a question if it will happen. The only question is when it's going to happen, usually via at Christmas sale or something like that. So whenever you're entitled to make lots of money. And you really need this system. But you also see that on the development level, by the way. It's not only on the business side, on the development side. So I had a situation like that in a project just a few months ago where they went for a microservice architecture. I looked into the architecture and said, how do you handle that situation if the service you call over there does not respond, or at least does not respond in time? And the answer I got back was a little bit frustrating. So I said, no, we do nothing. Because this other service is so important. If that service is down, we've got a problem. No, you've got a problem now because your availabilities multiply up. See that in a second. So, and the other one said then, yeah, and we would not be able to do anything useful anyway. It just needs to be up, so we have no idea how to recover from a failure from that, so on a functional level. I'll talk about that in a minute. So it's a sign for another of these challenges. So again, in a distributed world, the question is not if a failure has happened. The only question you have to answer is when it's going to happen. It will happen for sure. And it will hit you whenever you can use it the least. And just talking about availability, just giving you a short idea about availabilities, because involved peers, the availabilities multiply up. So why you need to make sure that you don't get cascading failures in your systems. So let's assume a service with 99.5% availability, including planned downtime, which nobody is going to guarantee you. So excluding planned downtime maybe, but not including planned downtime. Usually you don't get SLAs or OLAs like that. And you have 10 services involved in a request that you need to call internally before you can answer the original request. You're down to about 95%. So every 20 transaction is going to break in average. And especially they're going to break if you're on high traffic. So on high volume, when you're going to make a lot of money and you're trying to satisfy a lot of your customers, then it's where these other 5% are going to happen usually. And the 95 is only when you're not growing any money and there's no traffic around. And if you have 50 services involved, you're down almost to 75%, which means you've got every fourth transaction breaking in average. And again, it will break whenever you need it the most that it works. That's for guaranteed. So the only thing which is sure and not deterministic in distributed system is Murphy. Murphy is strong in distributed systems, and he will haunt you whenever you can use it the least. Okay, make sure that you address this 100% available trap. There is no such thing like 100% availability in distributed systems. You have to be aware about that, and you have to address that whenever you see that somebody says, yeah, we need that. We assume that everything around us is available and even my stuff's available. No, it won't be. Another one is more on the organizational level. I avoided the term DevOps at the moment because I think that DevOps is a very, very valuable thing, but it's misused in so many places. So therefore, I turned this wording around. So establish the ops dev feedback loop. The problem I want to address here is this wall between the dev department and the ops department, which you still see quite often these days. I mean, originally that came from creating cost-efficient organizations, so an industrial approach, how to organize work, which is okay, which has its advantages regarding cost efficiency. But if you think about availability, robustness of distributed systems these days, it really backfires, this kind of organization. It also backfires a lot of different places, but it especially backfires here. So as a prerequisite, as I said before, you cannot solve availability issues on a distributed landscape simply on the infrastructure level. What you need to do instead, you have to have dev and ops working together. So you create some kind of a build, measure, learn cycle. The build, measure, learn cycle basically goes here at the dev on the dev side. You're going to implement some resilience measure, and hand that over to production and say, here I implemented something which should make your life better at production. So giving you higher availability. On the ops side, you usually have the monitoring where you can see if it worked or if it didn't work. And ops is going to deliver you back the figures. Here is how it works, what you just did. And you, again, use those figures to see, oh, that wasn't the most brilliant idea I had before, so let's maybe change that a little bit. Oh, that worked quite nicely. Let's roll it out and use it also over here, and so on. So it's a continuous improvement cycle. And if you have the wall in between, yeah, that cycle is basically broken. On the dev side, you have access to the application level and where you implement the resilience measures. On the ops side, you have the access to the infrastructure level and the monitoring where you will figure out how it works. So, yeah, it simply breaks the cycle. And the worst thing is, as a developer, I'm just shooting in the dark. So I'm just sitting there and saying, yeah, I try to create a more reliable or available production system. And yeah, well, I've got no idea if that will ever work, what I'm doing or not, because I don't get any feedback. I need the feedback to learn about that. And the worst thing is then if the dev side gets incentivized for being fast and the other one's getting incentivized for being available or punished if they're not like that, then you're in the total hell regarding that. So welcome on having highly available distributed landscapes with a setting like that. So the bottom line of that is you need that working ops dev feedback loop. I mean, there are several ways how to implement that. You can't use DevOps. I mean, the original idea of DevOps is not that feedback loop. The original idea of DevOps is, in a post-industrial world, your problem is no longer cost efficiency in production. The problem is to produce the right thing, because you have a highly dynamic, fast-moving market. And so you have always to continuously figure out what's the market wanting from you and to adapt to these needs and demands of the market. And therefore, your most important concern in software development, which basically is in everything these days. So we are basically the nervous system of every company. So no matter if we support people who are out on the market or if we are on the market, so digitization, we are part of the digital product we're delivering, is our most important concern there is how fast can we bring an idea through the whole IT value chain out to the customer in order to get feedback from the customer and learn from that. So it's not about how cheap is it to produce a feature, but how fast can I go? And that is DevOps. But DevOps is a big revolution in thinking, because it turns basically everything upside down, or at least turns by 90 degrees what we ever learned about organization, about processes, about technologies, tooling, people, how we educate people, blah, 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 blah. And everything like, that's a huge thing. And there are quite some people who say, no, I don't want to go that way. So also decision makers are often afraid of that because their traditional control structures dissolved by that and so on. So it's a huge... But at least you can adopt site reliability engineering. Site reliability engineering from Google is a nice thing which basically focuses on balancing innovation speed and production robustness. So it's a smaller approach, basically. So it looks a little bit more traditional. They still have the SRE teams, which look a little bit like ops teams, and you have the product teams, which are more like the dev teams. And you have some rules and principles and guidelines in between those, how they interact with each other, and when they are going to when they are allowed to go fast, and when they have to slow down, and help making things more reliable and so on. It's a nice approach. There's a whole book about that. Or if you have a better idea, do it however you want to do. But you need that feedback loop. If you don't get the feedback loop on the organizational level, you're toast. You don't even need to start with resiliency. You say, okay, let's move on with our system landscape. Let's try to get monolithic again or something like that, and not talk to any other system except by batch jobs or something. Then it's perfectly fine, that setting. In all other cases, work on that. Okay, number 5. So coming back to what we are actually doing and not what we are just influencing. Functional design. This is a huge one, by the way, and a really, really hard one. It's almost as hard as distributed systems in themselves. So that's what I see most of the teams struggling with. So no matter if they pick up the idea of distributed systems or not, basically every design I see sucks on a functional level. It's a hard thing. There are brilliant technical designs which suck on a functional level, which is very, very sad. And the problem is, we haven't learned how to do good functional designs. So my claim is, without proper functional design, nothing else matters. You don't even have to start with your circuit breakers and back pressure and everything you maybe have heard about. So what's the problem? Problem is, the core idea of making systems robust, so this landscape is you have to implement isolation. Isolation, so that the idea, your system must not fail as a whole, therefore you split it into parts, and these parts needs to be isolated against each other, using against each other with respect to cascading failures. So that's the core idea, basically. I mean, it makes sense if you think about it for a moment, okay. The whole thing, if that crashes, is a problem, so let's split that up. And if just one thing crashes, the rest still lives. on and maybe can detect that one has crashed and take countermeasures and so on. Okay, basic idea. And you use the bulkhead pattern to implement that. So bulkhead pattern basically says create failure units and implement bulkheads in between using different patterns. Okay, interesting thing is the last one here. Shaping good bulkheads is a pure functional design issue, and it's very hard. And now you might say, oh, well, no, I slice functionality the whole day, from morning to evening, so in classes and methods and modules and whatever, so whatever you're doing. I do that for 5, 10, 15, 20 years, or how long you're in business. And so why should that be hard? Well, how do you avoid this one? So the service A gets a request from the outside, and in order to deliver a result, it needs some information from service B on a functional level. Have you ever seen that? I guess yes. So, and because if you have that, if service B is down, you can have a million circuit breakers between service A and B. The only thing that your circuit breaker is going to tell you is, hey, service A, you're dead now, which is a cascading failure. Bad. Or how do you avoid this? Oh, wow, this service is a big one. So let's split that up into smaller services, which, oh, they're still quite big. Let's split that up. I mean, we have learned how to do that, creating small, understandable services and connect them to each other. Problem is here the availability thing again. I mean, here's a long activation path, so a lot of service needs to be called. And you know the availabilities multiply up. Oh, that's also not so good. So you have these availability issues by having that around. So maybe you will put some more stuff together and more to get rid of the fragility of your runtime system. Oh, darn. You just ended up here, which I also see quite often. But you still will say, no. We have learned how to do that. I mean, we have learned in Computer Science 101, divide and conquer, so functional decomposition, or we are software craftsmanship, so we do apply dry principles, so don't repeat yourself, or you're more like an architect and do the same thing, but in a more fancy way. So like, yeah, I do design for reusability, so this old holy grail of software architecture, which didn't work for the last 40 years, will never work for the next 12, 40 years, at least if applied on these kinds of levels. It works on different levels, but not there. Or layered architecture, so and okay, it doesn't work perfectly, so the two ones left and right, and so on. Or you say, no, I'm using TDD or emergent software architecture or software design or something like that. But don't think that you get, on a magical way, a very different design. You will implicitly then apply all these techniques which you have learned before and create your design. So there's nothing wrong with TDD and emergent software, or better evolutionary software architecture and stuff like that, but it will not magically give you a different design. So the problem is, this is dry and designed for reusability. And this is basically functional decomposition and layered architecture. And while you find yourself in production with a system with high coupling this way and loose cohesion, which is quite the opposite of what you want to achieve, you will then try at least to get the cohesion a little bit better. And yeah, here we are again. So, welcome to distributed hell. What I've seen is basically most of the things that we've ever learned how to design systems in terms of splitting up the functionality work very well inside process context, inside a process boundary, but don't work very well across process boundaries, because all these design techniques do not incorporate the non-determinism in the communication in between and things that can go wrong. Here you really need low coupling, high cohesion. And while everybody says, yeah, I know what that is, I haven't seen mostly anyone who really knows how to do that. I mean, the oldest papers are about 50 years old about those stuff. So back in the late 60s. But we still haven't solved that really. If you expect, one more thing, just to mention that very fast. Some people then come along and say, yeah, No problem, we've got caches, so that's no problem. So we just implement a cache in here. So if service B is down, then we take the response from the cache we have at service A. And everything's fine, so we don't have to solve that problem again. Really? So, I mean, caches, don't get me wrong, caches are an important measure in distributed systems and also in a lot of different places. But do you really think that this is a good idea to fix an inherently broken design? I mean, you will end up with a lot of caches then if your design simply sucks on a functional level, because everything you will have to fix that high coupling problem that you have between the services. And caches are stale by definition, so you have consistency issues, you have to copy around a lot of data, and. So you will be back in a different hell. So one hell exchanged by another, which isn't a good idea. So basically we have to relearn how to do these things on distributed systems. So because I don't have the time here, there is no simple solution for that. Things like DDD and so on might lead you the right track, but there are also no panacea. So sorry about that answer. So we still have to put a lot of effort into learning how to do that as a community, how to do that better on a distributed level, not on an in-process level, which makes a real difference. Number 6, about time. Now we're down to the patterns. The problem is there are just too many of them. And applying all those patterns, it's just from one of my slides. It's incomplete, by the way. There are a lot more than these. And applying all of these will leave you with an unusable system for sure. So how to use all that stuff? And just a few words about that. So first of all, if you know some patterns, they are options, not obligations. I've seen too many people who are so tempted to use everything new they've seen that they end up with unmaintainable systems, which are, on the other hand, also poor at runtime, usually then. So don't pick too many of them, find a few ones, because that's an important lesson. Each pattern increases complexity, and complexity is the enemy of robustness. The problem is, in order to create a robust system, it must be simple in some way, simple in terms of understandable, because if you don't understand your own system, you're very likely to create a non-robust system, which will be brittle at runtime. And so you have to balance the need for patterns on the one hand and the need for a simple system on the other hand, and try to figure out the right balance between those two things. So if you ever think about becoming a software architect, that's basically what you're doing, finding balances between opposing forces. If you don't like that, okay, you're welcome, do whatever you like to do, but please don't try to be a software architect then. It's a sad truth. So it's not always the coolest thing becoming a software architect, really. So, and all these patterns cost money, of course, and you only have a limited budget. We've seen that. So you need to try to figure out a set of complementing patterns which help you on this way. So like, for instance, if you look at the Erlang virtual machines or Acker, which partially implements that, re-implements that stuff. So they use actors and messaging as their failure units and communication paradigm, and then they have this let it crash pattern, which is then just a handful here, combination of monitoring, escalation, and restart logic. They have a heart beating between their virtual machines, and they have hot deployments in there, which is a nice feature of the Erlang VM, so you can deploy code into it without restarting the virtual machine. And that's basically it. And they were able to create systems, telecommunication switches with 9 nines of availability, 99.99999, also 7 nines after the comma, and after the decimal point, and of availability, which is several milliseconds down per year, which is a great thing. Just a few patterns. Or Netflix, popular these days, services and request response. Due to the request response, so basically HTTP-based communication, you have to put a lot of effort into figuring out if they run into latencies, so timeout circuit breaker, limited retries, fallbacks, bounded queues, and stuff like that. They're using that's basically baked into the Hystrix library if you are ever heard about that one. And then several kinds of redundancy you're using, for instance, for sharing loads, so firing up new machines when needed. A very good, decent monitoring, and while they're not having hot deployments, you use zero downtime deployments, and the simian army, so the error injection at runtime, which basically is also still just a dozen patterns they're using. It's a different use case, a little bit more complicated, but they're not using 60 or something like that. It's quite limited, and it's complicated enough already. Okay, let's come to the last quest, where I have no clue how to solve that one. Preserving the collective memory, and that's what affects us in all places, not only in resilient software design. My claim is we lose our collective memory every 5 years. So that's the meantime until a topic discussion in the community starts over from scratch. So I'm in IT for more than 35 years now, so I've seen that happening over and over and over again. So we can discuss if it's 4 years or 7 years or something like that, but if it happens over and over again, that you come into a discussion about a topic which you've heard 10 years ago, 20 years ago, and also in between, and it sounds like, oh, have we never discussed about that before? And problem is, at least how I understand, try to explain it in a simple way. If we are working in IT, we grow our knowledge. I mean, that's basically true for every kind of domain we're working in. So we grow our knowledge in time. The problem is, hopefully we do that. I mean, we have also quite often people who grow the knowledge like that. So in the beginning, and then it flattens out. But let's assume we learn all the time, like we're told. The problem is, creating wisdom, insights from the knowledge takes longer. So you have to collect a lot of knowledge before you really can create insight. That's typical for every industry. So we have to find a way to preserve these insights and deliver them to the next generation. And as a community, how are we going to compensate for this problem? Yeah, whenever we hit a new problem, we say, hey, where's the new panacea, a new silver bullet on the horizon? Where's the new cool stuff? Because everything that's old, which is older than, say, 2 years, or in JavaScript world, older than 2 months or something like that, must be crap. So, and if I come along and tell you something like, hey, have you ever looked at that solution, at this concept, which is 40 years old, and you say, usually probably would say, oh man, old man, go home with your walker to your retirement home. It doesn't make any sense. No? And the problem is, we have no way to preserve our insights because of this youthism also in technology, not only in people. So basically, the consequence, we have to rediscover all these insights every 5 years. I mean, also resilient software design, the concepts are not new. They are partially 40 years old and older, but we have to rediscover them over and over and over again to apply that to our current problems, which are not so different from the old problems that we had before. So I usually tend to say, so yeah, in IT, we suffer from continuous collective amnesia, and we're even proud of that. Yeah, we're cool, we're fast moving. We forget everything we've learned before. Okay. Question actually is, how can we become better than that? Because what I think is, if we really want to become an engineering discipline, we have to solve that problem. How to really preserve that wisdom and these insights and deliver them on. I don't know how it should really work. If you have an idea, please be here at the next DevTernity, share it with the people and try to help them to get on this way. So, I mean, there's a lot of stuff to be forgotten in the past, but we also forget the insights, which is a problem. So, okay, let's wrap up. I mean, it's about time to wrap up right now. What's a lot of stuff I've walked through, some rather technical in their solutions, some more on an organizational or commercial level or something like that. How to preserve the collective memory, big issue, basically. A few more words about that. So, yeah, it's not easy to get there. I mean, it's not easy with every innovation you have, especially, but resilient software design gives you some extra problems or pitfalls or challenges, quests. So most of them are not really related to coding something into your system, but which is also true for many of the situations you will face in your professional lifetime. What I've seen, what I especially want to stress, because we really have that at our own hands and don't have to convince manager or something like that, especially as a community like you are, is functional design. So when I look at the software development trends, all this stuff will go into the infrastructure level more and more. So if you have the Kubernetes in place or the serverless revolution, which is on its way, if you see what AWS just launched the last days with Fargate and so on. So we'll have to manage less and less of that stuff. But until you're able to get your functional design right, you will still suffer from brittle systems, no matter how good the infrastructure is. So we really have to learn that. We really have to figure out how to do good functional design. And yeah, we have to think about business logic and not just put a bubble there over in our diagrams. Oh, here's the business logic. We really have to dive into that one. Sorry about this. And we have to solve this idea, how do we preserve our insights? Again, if you have an answer to that, please share it. We really have to learn that. I don't have a perfect answer for that. But still, I hope I gave you some more food for thought, as Kevin said that before. And by having an idea what are the challenges, you're already on the right track to solve that. And that was my intention with this talk. And hopefully it gave you some ideas where you want to pick stuff up, where you want to dive deeper into it, and so on. I hope you had enjoyed that somehow. If you want to pick up the slides, they're on the SlideShare account. Thanks a lot for your time and for your patience in this crowded room. Thanks a lot.
Thank you. Okay, we have actually some questions in Slido. The first one, I guess, which gets the most votes, is any general guidelines about how to react to failures from a service which should be up all the time?
The guideline is usually to bring it down on a controlled schedule. I mean, that's what Google, by the way, did. They had that Chubby service. And Chubby is a distributed log service. And what they figured out is a highly reliable service, but they figured out, oh, whenever Chubby is down, about 70 of our other systems are also down. Coincidence or not? The problem was that all the other systems blindly relied on Chubby being available. And the cure that basically Google implemented back then is, they said, we will take down Chubby every day for 10 minutes. We will not tell you when it will be. And after a few weeks, there was no problem anymore. So all the other systems stayed up.
So it's something similar to Chaos Monkey, but
it's a different measure. So it's a sort of this chaos engineering thing. I mean, that's the only thing. Again, no 100% availability possible. So you can reduce the probability of being non-available of the non-availability of a service, but you have it no longer in your hand to make sure that it will never be down. It will be down, period. So better have a plan what to do when it's down.
Yeah, the next question is there a way to deal with managers who refuse to see the value in removing possible losses? What do you do usually?
It's a tough one. Sometimes you win and sometimes you lose about that. So I can't say that I have the perfect way to deal with it. What I've seen which works quite well is trying to understand a little bit about that. It's called empathy. That's this strange thing. Yeah, we really have to pick that up in a cross-functional world. To understand what's their motivation, what's their needs, what's their questions. Why are they asking this stupid question? And if you understand it, quite likely it won't be that stupid anymore. And if you really give these people the right input in his world, in his terms of thinking or her terms of thinking, then quite often you will be successful. So, like I had in one situation where some manager just said, I want to have a microservice landscape for no reason, just because it wanted to have the term on that. And I discussed with that was a manager who was a little bit by bullshit bingo driven. But I said, okay, I will tell you what a monolith means and what a microservice landscape means, and the pros and the cons, what you get, what you pay for that. And after 10 minutes of discussion, I asked him, okay, what do you actually want? And he came along and said, I think I want a little bit right of the monolith. Great. So it's helping those people to make the right discussions. And again, if you want to become a software architect because that looks nice and shiny on your badge or something like that, you really have to do that. Helping people succeed.
Okay, I guess we're actually running out of time. Maybe last question. Can you explain a bit the Byzantine failure pattern? Because I don't think everybody knows what's that.
Okay, Byzantine failure. Yeah, that's... when your system runs amok, it's named after a paper which Leslie Lamport wrote, the Byzantine generals problem, which is if you need consensus between several parties. In this paper, he had the metaphor of four Byzantine generals who each controlled an army which attacked a city, and only if at least 3 of them attacked at the same time, they would be able to successfully get into the city, and otherwise they would be defeated. And one of the generals played wrong, so was an ally, a hidden ally of the city, and they communicated by messengers, so messages, basically, and said, is there a way to figure out if somebody's playing wrong in your system and isolate that? And it's a whole different kind of algorithms that come from that. So the core idea is you have to have at least 4 parties for that. So usually your quorum is, so you have to be a majority, you have to have more than a majority usually with that, and then there's very specific algorithms to figure out if some party in your system behaves badly, voluntarily or involuntarily. And so, but it's a different class of algorithms, which I'm usually not covering, but there are good papers around that. So just Google Byzantine failures and you will get all the information about that.
Okay, thank you very much.